All right, welcome to the last session of this day. This session is a bit of a spontaneous thing. We didn't know that we had the session until like 2 or 3 weeks ago, but it may be a good way of putting the idea of a workshop back into the conference thing. So this is going to be as lively and interactive as you want. And the rough topic will be GHC proposals. So let me briefly give you an introduction to what is the GHC proposal process and what are we going to discuss here and what's in scope and what's not. So I'll give a quick intro. We have 4 proposals that people actually want to definitely discuss. So they will come or send a video and briefly explain to you what it's about. So you don't have to know these proposals already to join the discussion. And then we can discuss. And I'll keep each of these time boxed to maybe 10 minutes. If there's more discussion in 10 minutes, that's great, but then we can defer it to the end, to the open discussion, when we've seen all the things we can discuss and maybe also got other topics. And then after these 4, we basically have half the session left for open discussion, and I really hope we can make this an open discussion, maybe a bit like the future of Haskell sessions that we had at earlier Haskell symposias. So anything related to evolution of Haskell, of GHC, to concrete proposals, to things you want to see, things about the process, things about the general direction will be welcome, and I hope we can have a good conversation. For those of you not deeply familiar with the whole process, I'll give you a quick overview how this governance body of GHC tries to do its work. So we have a committee. It's usually around 9, 10, 11 people, depending on when people drop out and when they vote in. A few of them should be here. So I've seen 2 Simons. I'm here. Then Richard is here, and that may be all. Oh, Arno? Arno is not in. Okay, he'll probably join in a moment. So these are the people you've seen. Our main place of discussion is the GHC Proposals GitHub project, as it is normal these days. So when people make proposals, they create a pull request, adding a new document to this thing, and then there's a process happening. And if you like it, it gets merged, and then it is accepted. And you can go to this proposals directory and see lots of accepted proposals. It's always helpful to know the scope of a certain process or a group. So what's in scope is, of course, everything that changes the language. So adding new syntactic features, changing how type resolution works, all these things. Usually things that you will see as a language extension. So if I say language extension, who in the room does not know what I mean? Anybody who's bold enough to raise their hand? Okay, so we're all Haskellers here. There's nobody like poaching us from other groups that needs. Okay. I mean, I could do more explanation, but it's pointless if everybody knows what the -X flag is. So I'll skip that. And the scope is this is definitely in scope, and there's something in scope like big changes to how you use the compiler, maybe changing to the warning systems or so could also be in scope. What's not in scope is changes to the library, including the base library. So there's another committee doing that. We have lots of committees in the GHC world, and we seem to be liking that. So if you want to change something to the base library, you have to go to the core libraries committee. What's also usually not in scope is performance improvements, like just a new compiler optimization that does fancy things, but doesn't change the semantics of your program. That is something that the committee would usually just say, well, talk to the developers. We don't need to be involved. You can still come to the committee and ask for our opinion, and the committee is full of people who like to give their opinion to things. So usually that'll work, but you're not obliged to. And similarly, like GHC build system, CI stuff, all these things are not necessarily part of the GHC proposal process scope. So the rough workflow is very unsurprisingly, somebody has an idea, they draft a pull request with a document. There's a template you can use to follow a certain pattern. And then there's a discussion phase on GitHub. And this is open to the community. So anybody of you is very welcome to subscribe to the GHC proposal process repository and see what's happening. And when somebody proposes something you like, then tell them that you like it. And if more importantly, if somebody proposes something you don't like, then tell them you don't like it, and ideally why you don't like it. And as a committee, we're happy when all the discussion has already happened before we get involved. So ideally, there's lots of discussion happening before we get involved. Ideally, the author actually beats the drum about the proposal on Twitter and mailing lists and Reddit and Discourse, so that all the people who might be interested in this feature will actually join the discussion at this point. At some point, the discussion on GitHub kind of ebbs down, and maybe everything has been said that needs to be said. And then they get to submit it to the committee. You do that just by saying, I want to submit to the committee, and you tag my name. And ideally, I don't miss the GitHub notification. If I do, then just tag me again after a week or two. I assign I have this extra role in the committee of being the secretary. So I try to make sure the process is being followed. So that's why this is always something I'm doing so far. I assign a shepherd. Shepherd is someone on the committee who I very randomly and using an undisclosed algorithm assigned to this proposal. And their task is to then make sure this proposal goes through the process. So the idea is that there's always one person who's supposed to be doing something. Because once there's two persons supposed to be doing something, then nobody does something. So their task is then to look very carefully at the proposal, clean it up, maybe get feedback saying, well, this is still vague, you need to fix that. They can give feedback if they know how to do that. They are supposed to give feedback, yes, sorry. And then the important thing is they make a recommendation. So they go to the committee and say, I think this should be accepted, or I think this should not be accepted. This way we always have like a decision to refine rather than, what do you all think? Which then usually leads to no responses. The committee then deliberates. This happens mostly on the mailing list, which is public. You can read it. You can even post to it if you have something to say. The idea is a little bit to make this like, we meet in a room and we discuss. It's not secret, but we want to keep it focused among the committee. So other people are encouraged to comment on the GitHub thread. And then we say yay or nay, or maybe needs revision, and then it just kind of be resubmitted later. And this is roughly what's happening. Simon and I had a brief discussion on like committee activity, and he suggested we make statistics on like activity of the committee. So this is on the mailing list over the last 12 months. And we see that's mostly committee members doing stuff there, or former committee members. I think John sent one email, although he's not a committee member, which is fine. You can do that. And it's not maybe the distribution we want to see. Maybe that's a discussion for the open discussion round. Here's the same discussion, the same statistics on GitHub. So the good thing is there's lots of people who are not like massive contributors, so it's a bit more open. That's great. Actually, the most active person on the GitHub is not a committee member, which is, I guess, also a good thing. I'm not listed here because I sourced this data from the notifications that GitHub sent to me by email, which doesn't include comments that I make. So I have no idea where I am on the scale, but it's not that relevant. Right, this was my very brief introduction to the GHC proposal process. If there are any questions you have right now to make sure follow maybe what follows next, you just go ahead and ask. For the remote attendees, I'm gonna monitor the AirMeet thing, but only when I'm sitting there. So when I'm sitting here, you have to, I guess, wait until I'm there, or somebody else maybe also on AirMeet and relay questions. If there are no more questions, then we can look at the first proposal that Gergő Erdi wants to present. And he actually has slides, which I think I have here. I just have to find out how to present. No.
Joachim, I can also look at the AirMeet.
Okay. Yeah, but I can do it now since I'm now giving way for Ergő.
Hi. So this is much more intimidating. I imagined like 10 people in a seminar room for this, but okay. So partial type synonyms. So here's the idea. So you can make partial type signatures, right? So here we have an example where we say that map goes from something to a list of something to a list of something, and these somethings are filled in during type checking because they basically become meta variables, and then the type checker will solve them to whatever, if it can be solved, if your program can be well tied with the constraints that are not the wildcards. And so partial type synonyms would be type synonyms that allow abstractions of these partial type signatures. So like in this example, the type synonym transformer F is F wildcard to F wildcard. So then the type of map is something to a list transformer. So what does that mean? How does that work? So the idea is that if you write a type synonym which has these wildcards or holes in them, then they basically become extra type parameters of the type synonym, like under the hood. Like, okay, so this is like explaining what they would mean. And then whenever you, for example, write transformer list in a type, it actually expand to this expanded form of transformer prime of list and two holes for the two wildcards that were in the original definition of the type synonym. So, and just for the sake of this talk, so this is not like, okay, first of all, there's no proposal yet. So I'm workshopping this so that I can write a better proposal. But for like level 1 of the proposal, there is no, like, this is not surface syntax, right? This part. Actually, yeah, so this part is not surface syntax. But just for the sake of this talk, just to explain what exactly they would mean, I'm going to use this syntax, again, not Haskell syntax, that when you write this, it's as if you wrote this. So this is, again, with two extra type parameters, but they are named. They just are in these braces. And then refer to them on the right-hand side if instead of just putting underscores. So you can think of this as like the elaborated version of this. And then, of course, at an occurrence side, you can think like when you write transformer list, it elaborates to, well, now it has 3 parameters, so it needs 3 arguments. So the first argument is given by the user, so that's going to be list. And then the second and the third arguments are going to be wildcards. And so, of course, the order here, like the order between F and the 2 wildcards, it's not just some bag, right? Because they can form a telescope. You can have like kinds that, like you can have types whose kind depends on other wildcards. So this is not, like in this example, you could put these two anywhere because, here the F and the 2 wildcards don't form a telescope, but in full generality, I just want to mention that they can even be interspersed with the, like they might necessarily be interspersed with the non-wildcard originating parameters. So what does that mean? Well, the nice thing is that we know what it means because I've shown you the elaboration. So if I were replacing this with this, like in my program, and then I wrote this at some given point, it already has a meaning. In particular, we know which types are valid solutions to these underscores, right? So there's no confusion about like type variable levels. The only source of confusion is that how far do we expand in the elaboration? But luckily, even that is answered for us because it's already true that a type synonym has to be fully applied. So there is no ambiguity because if you just write transformer list, it needs to be expanded all the way to all the wildcard originating or implicit or whatever we want to call them parameters. Okay, so what happens if you use named wildcards? Well, then they are the same wildcards, so they become the same parameters. So if you want to give a type synonym for monomorphic transformers, then you use a named wildcard, and now we only have one implicit parameter, and then of course that's referred to at both positions on the right-hand side. Okay, so surface syntax, everyone's favorite bike shedding topic, right? So what is the kind of transformer? Well, like I guess something like this. So F is, we know the kind of F, so star to star, and then we have 2 extra star-kinded parameters. So we can, here I use the brace syntax, but the idea is that you would use something to mark them. And then there are a bunch of surface syntax extensions. So again, and this is the part which is not really going to be part of the level 1 proposal. But if we think about like other ideas that this unlocks, so we could allow the user to bind these implicit parameters explicitly. So instead of writing transformer f equals f underscore to f underscore, maybe we care about where those parameters are put, and maybe we care about their names, in which case, why not give surface syntax to bind them? Again, just marked with some extra syntax, like braces here on the slide. And then the dual of that is maybe you want to give, like the user might want to give a solution to a wildcard parameter. So, for example, we could say that the monomorphic F transformer is an F transformer with two named wildcard arguments that are both the same, right? So this way we can express, this in terms of, well, the one that was on the previous slide. Or we could go full Agda, and we could say that the names, like to make, because usually you wouldn't give this, so you might think, okay, well, I'm not gonna really know which one is which, so maybe we want to include the names when you do explicitly specify them. So maybe if you write transformer, like if you define transformer like this, then you could use it like this. So so here you say that I want to explicitly say that B should be bool and A should be int, in which case, transformer B equals bool, A equals int list means it's a function from list of int to list of bool. Okay, and in terms of implementation, so there's a work in progress implementation that is otherwise validate clean. The implementation is mostly going with the grain of GHC. There's only one part where it feels like it goes against, and that is the question of how to represent these implicit binders on the kind of a type synonym in Tycon. So basically, when we make the Tycon for transformer, it's not it's not enough to on the binder to store that these two are implicit. The kind itself has to know that, but that means we kind of open a whole new can of worms, because now every function, like not just the type level function, every function can have these implicit arguments. But maybe that's a good thing, because if we move to dependent Haskell, then if the more tight your types are, the more arguments can be solved by unification. So maybe we'll at some point want to use these on the term level. Again, going full Agda. And then isn't it nice that we now have like a tiny sliver of that for type synonyms? So you can track the implementation. There's a draft merge request. And formal GHC proposal is coming soon after we have some discussion here, so it's not dead on arrival. And that's it.
Thank you.
So how do we do this? So do we discuss it now, or
yes, let's just see what people want to say about it. And
okay, so Simon Marlowe has a question.
So you were very convincing about how we could do this, but I didn't see very much about why we should do this.
Okay. That's a good point. So that's one of the reasons it's not yet written up as a proposal. So basically, I have some work to do to extract the examples from our code base so that they're standalone, but I can give you a very hand-wavy explanation. So there are situations where you have some, like your types are tight enough to constrain. Okay, let me give you an example that, okay. So imagine typed relational algebra, right? And you have some higher order functions that change certain like column values, right? So then a lot of the times the type tells you the name and the type of each column. So if you want to, so the function that you apply, if you want to address your inputs and outputs, it's enough to give just the names of your columns. Whereas if you're in the middle of some composition of these higher order functions, you need to give, it's not enough to give the name, because the type is also relevant, because there's nothing constraining from the outermost type what this intermediate thing's type should be. So in that case, you do need to give both the name and the type of a relation column. But you can unify these into just one interface that always takes both the name and the type of the column in your types. You can unify them by just giving a type synonym, a partial type synonym, for the case where you don't want to give the type because it can be inferred from the larger context. And I think that pattern generalizes the pattern of, if your types are tied down enough, then you don't need to give certain parts of your type, but you want to use the same interface also in cases where you do need to give a full type, because it's in a context where there's not enough information from the outside, and you can give a unified interface by just always requiring all the type information, and then a partial type synonym takes care of the special cases where it can be solved by unification. But again, I know that's the shortcoming of the proposal, that there's no self-contained, nicely extracted example.
On the Army chat, Edward Kmet came and joined and said he sees a use case for that with lenses, where you have certain kinds of lenses with parameters you don't care about mostly, I guess, if I try to... It's too much to summarize, and I failed to summarize it, but I guess the summary is that Edward Kmet thinks this might be useful in cases in code.
That's good,
Edward
because
writes.
he wrote on the mailing list that he has some use case in mind for this, but he never described what it is. So does that mean that you have some details now on Hermit?
Yeah, there's something about complement lens constants, something, but I failed to summarize it.
Yep. Oh. Oh.
All right. My hot take is that I like it because it makes type signatures more uniform in different call sites, if you will. But I'm worried that error messages have entirely new ways to be incomprehensible. So is there anything in the hypothetical proposal to address error messages? For example, if I have a partial type signature like transformer, do I, the user, will I see things like transformer prime and all these things in the error message then?
Well, you certainly won't see transformer prime, because that, I mean, you will see in the error message, you will still see the thing you wrote, like transformer. And if you have a type error specifically from not being able to unify the wildcard that was inserted during elaboration, then you will get an error message that says that, like in this example, you get an error message, I guess, that says, where was it? Like, you get an error message that says that, instead of list of wildcard or list of anything, it's an int. So transformer will not show up, I guess, in that case, in your type errors. But I think that's true already, right? Like, if you have a type error from a type synonym application that's coming from deep within the unfolding of the type synonym, then you will get an error in terms of the definition and not in terms of the name.
Last question, maybe, and then we can come back later after we've seen some other things and discuss more if you want.
Are there any restrictions placed on the kinds of the holes?
No, because, so like I said, the implementation is already telescope aware. So, yeah, okay.
Thank you.
Okay, thanks for doing the first presentation. I'd like to cut this short just to give all the proposal like a fair amount of discussion. This does not mean we can't discuss it later when we have plenty of time for open discussion. I hope that's fine. So, thank you. And then the next, the next one is by Andreas Kleibinger, who unfortunately got ill, so he got special permission to do it remotely. He recorded something he wants to present, and then he's on AirMeet and will join the discussion as good as it goes there. And I hope he's getting better. So if you can start the video.
Hello, my name is Andreas Klebinger. I'm presenting the strict box denesting proposal, which is really a mouthful, which is about eliminating certain kind of interactions at compile time. It was authored by Matthew Craven. I'm presenting because Joachim basically asked me to. And also I'm involved in this work as well. I did a proof of concept for the implementation, among other things. But let's move on. So what's the motivation for this? Right. So the original motivation was that I wanted to make unlifted data structures more ergonomic to use. This was prompted by some work in the hash maps library where they want to use unlifted data types internally, but still be able to provide a lifted wrapper to users. And they want to do so without incurring a runtime performance hit because the hash maps library is really runtime sensitive for a lot of projects. But one of the issues that you run in with unlifted data types, if you try to avoid this by not having a lifted wrapper, is things like this, where you try to provide an eq instance for your type, but eq expects a lifted type. You have an unlifted type, so you literally cannot provide this instance. So one easy workaround would be just provide a lifted wrapper, right? Like I defined one here, right? We have one field that contains the unlifted hash map. I didn't provide an implementation for the hash map here, but right, it would just be like eq hash map, some sort of function that then takes apart the hash map wrapper, pulls out the unlifted hash map, does the comparison and returns the result. This is very trivial code. Everyone could implement that. Everyone that listens here, at least, I assume. But this wrapper can sometimes cause runtime overheads and space overheads as well. So we really would like to avoid that, right? One way to do this is to instead use unsafe coerce and basically unsafely coerce the unlifted hash map to a lifted thing and back. And this does work currently, but it relies on operational semantics that are currently in place in GHC, but it is undefined behavior to use things like that. Sebastian Graf has written a library that does that. Currently it works, but GHC might break it in the future, right? So I don't think it's a great way to do it. So really what I propose and Matthew proposes in his proposal is that we provide a workaround by allowing a lifted wrapper without overhead. So you write your same code, you write your lifted wrapper, you end up with one constructor with one unlifted or strict field. You can provide an eq instance, you can pass it to map, you can create a list of those, just as with any other lifted types, and you get at most the same overhead that you would have gotten from any other lifted types, but there's no allocation overhead for the wrapper itself, which is important. And it doesn't allow us to eliminate some overhead that's associated with having lifted types that can be things. Sadly, that's not possible without making Haskell a strict language, but that's okay, right? So how does that work? Like, how is that even possible? The thing is, if you have a variable x that points to a hash map, really the hash map is just an indirection to the unlifted hash map anyway. And we know that the unlifted hash map has the same kind of heap representation as the hash map itself. It's already evaluated, so we can't blow up the program if we evaluate it or try to evaluate it. So really we can just optimize this indirection away and just write instead the pointer to the unlifted hash map into this variable instead of a pointer to a hash map that contains a pointer to the unlifted hash map. I think the diagram is a good representation of that. And I have a proof of concept that already does that for types that are compatible. There's some limitations that the proposal talks about where we have to change some parts of GHC to make it work for things like byte array, but it's feasible. Right. So what we would like feedback on, or at least I haven't talked with Matthew too much about this. Is this desirable to you, right? Are you a library author that might want something like this? We know the hash map people would like to, but if someone else also likes to, then it's a motivator, right? It might accelerate this work. The second question is more of a design question about should this be controllable? Should there be a flag, a pragma, something that allows you to switch on and off this behavior? Or should it just always be on? It's easiest for the compiler, of course, if it's always enabled, right? But maybe there's good reasons not to enable this. For some things, One thing where this can cause differences is in profiling. So the issue with that is in profiling, the constructor essentially disappears. So if you do things like heap profiling with retainer profiling, then this can change the heap profile slightly. And maybe you rely on this somehow. If so, we would like to know. I don't think it's worth worrying about, but it would be good to, ask more people and get their opinion on this. It's also possible that, hey, you say, hey, I don't really want the compiler to optimize this away and to have users require this arcane knowledge of when does this optimization trigger or not. We will provide documentation for when, but that's fair. And maybe you would prefer like having premops that allow you to cast between lifted and unlifted types in a safe manner. And if so, that would also be good to know, right? Then maybe we can shift our focus to that if that has a really strong desire to have that instead. I think I already more than exhausted my time, so I will hand over to Joachim, I assume. I've recorded this in advance. I hope I can be present virtually in some way to answer questions, but we will see if we can set this up, and if not, leave questions on the issue tracker of the proposal, and I hope you have a good time at ICFP, and thank you for listening.
And I think, can you pass the microphone to Simon?
So just a little clarification, because it wasn't. So the idea is that this would apply to data types, algebraic data types that have a single constructor that has a single field that is an unlifted or possibly strict value, and that is itself a heap pointer. Under all of those circumstances, then there would be a promise under this proposal that the data type was implemented by, well, nothing at all. I wasn't completely clear from my address, but I thought I'd just share that, because that's why he says maybe you don't need a flag at all, because under all those circumstances, your program will mean the same but run faster. Who would not like that? Well, maybe if you want to profile how many copies of that constructor allocated. Does that make sense?
And is it the case that the only reason not to use a new type in that case if they have different if they have different kinds, so you need to do this unlifted to lifted thing?
Can you hear me?
So this is all, as far as GHC is concerned, until that moment, it's got case expressions. Until the code generator happens, it's still got case expressions and is doing evals. If it's a new type, then that's done by a completely different mechanism involving casts. There are no evals, so it's much simpler to do what he's suggesting here,
right?
And not try to persuade it to look like some kind of inhomogeneous new type.
He writes also there are very tiny strictness differences for new types.
So, at what stage is this envisioned to be implemented? Not core, presumably.
No, right in the code generator.
So, okay, so if it's
the last possible moment.
But Simon says in the last possible moment, right in the code generator.
So, does that make it less compositional or something? Like one of the reasons that we have casts in core is that we can move them around, and then maybe eliminate them or something like that. I don't have a concrete example in my head, but it makes me worry that we're leaving a little on the table. But maybe getting something is a lot better than nothing, so that might be good enough.
So Andreas says the proof of concept is implemented at the STG to CMM, C-minus stage. Yeah. He also points out that it can be that there are multiple fields if some of them don't, if all but one of them don't have a runtime representation. I guess there are some 0-bit values that would not show up or something.
Yeah. And that's actually useful. There are some examples in the proposal where there are some proof fields that. But to answer your question, Richard, for casts and coercions and new types can do more. Right? You can take a list of ages and coerce it to a list of ints by doing, well, nothing at all. But here, if you've got a list of pointers to age thunks, you wouldn't want to convert them, with doing nothing at all to a list of actual pointers to evaluate things. That's not going to work at all. So that's another good reason for not trying to wedge it into the new type world. There isn't money on the table. It just wasn't there at all.
Okay, maybe one more.
Probably a quick clarification. This changes the semantics of a data type with a single constructor with a single field, doesn't it? Because it cannot have bottom anymore.
But it's an
A single-
unlifted or strict field anyway.
Yes.
So it
But I would naively expect that if I have a data type with one constructor with one field with an unlifted field, that the whole thing can still
Oh.
be bottom. Whereas if you now erase the whole thing, then it cannot be bottom anymore.
right.
Or am I misunderstanding? That's also very possible.
Yeah, I don't know if you heard it in typing, but you can try to answer it if you're faster.
So I think, sure, it could be bottom. So. Right until that very last moment, right, just before the code generator, it's simply got type, whatever it is, hash map, a lifted thing. You can build funks of it and so forth. And just at that last moment, we're going to not allocate the constructor. That's all. So it could be, and of course, if you actually need it and are going to evaluate that thunk, then you have to evaluate the field anyway. So no, it does not change the semantics, is the short answer. And that's a good question, because we don't want to change the semantics. So no.
Right. Yeah. Andreas puts it this way: the the constructor is allocated after the field is evaluated, so there's no difference in behavior, as Simon said. Okay, I suggest we just go to the next one, and again, it's always okay to go back to these particular questions in the open discussion. And the next one would be. Yes, you can. Okay, so Matthias wants to talk about extending HPC for fault localization, and
David Binder is
yeah,
my co-author.
there you do your stuff.
Okay, right. So I didn't have a proper slides, but I have some links to show. Right. So we talked about this at HIW, right? Like these trace things. And now we're trying to write up a proposal for it. And the main thing is that if you have this flag, well, it changes the runtime semantics, right? Because if you have HPC now, it just bumps a tick in an array. But this will, do more stuff to keep track of more trace stuff. Yeah. So my motivation is I want to do fault localization, and you want to say a bit about what you want to do?
Yeah, so my main motivation is, maybe you have already seen this on the GHC issue tracker, is to revitalize the development of the HPC ecosystem of the library and the binary. And I'm especially interested in other applications than just counting how much code is covered during a test. So for example, there's fault localization, spectrum-based fault localization, where if half of your tests are running through and half of your tests are failing, and you know which tests cover which parts of your program, the failing ones and the successful ones, then you can compute some statistical measures and point to likely sources of the errors.
Can you move closer to the microphone for the benefit of the remote participants?
Should I say it again? Or?
No, but
Okay.
in the future.
Okay.
Sorry.
Yeah. So we're in the opposite end of the spectrum from the first proposal, right? We have a lot of motivation, but we don't have implementation, right? But I just wanted to show you, kind of the motivation here. So this is from ICSI, right? And this is like we're doing automatic program repair, and this is like the key step, right? We find failing properties, we generate examples for which they fail, right? And then we instrument the code using Haskell program coverage, and we do this fault localization step, like to figure out what exactly went wrong when this happened, right? And now we want to, it's very crude because it just says, here are all the expressions in the program that were, touched when this fault happened. But, the intuition is that things that happened more recently are more likely to have been involved, right? So we want to be able to know, in what order happened, what happened recently. And then there were some comments at HIW about, what if we had the whole trace and then we kind of kept a pointer in the thunks to, where in the trace were they created, right? And that's that's one alternative, and it's a lot more invasive, I think, like to GHC itself. So yeah, so we just want to present it and then get more feedback from the community, right? Because it seems so yeah, the main thing is we're trying to do software engineering things, and they really like these fault localizers, and we have the chance to very cheaply build it into GHC because Andy and Ransom, and they already did all the work for HPC, right? So we could just have it, right, with a little bit of change. But it involves changing the runtime semantics when HPC is enabled, and it involves specifically changing the output of HPC. Like the TIX files have more information in them, and the way that's implemented now, it's just a read and show instance. So it's very hard to extend the file without breaking every other tool. So we want to propose a more extensible file format so that we can build more kind of clever tools on top of these things, right? Yeah. So, yeah. You have any comments? I guess.
So I guess for GHC, you don't want like to add this as a feature to GHC, but you want to extend GHC to allow this feature in a separate tool.
Yeah, exactly. So
Okay.
you want because yeah, I mean, so there are other ways to do it. You can do full program transformation and like add tracing, but that's but one of the reasons for HPC originally is that that costs a lot, and it really might change a lot of the semantics of the program, right? So we want to build on top of that work to have like a scalable thing that you can just pass a flag that goes through the entire build chain, right? So you don't have like just one file that was transformed, everything works, and then yeah, just a small change that can enable a lot of nice analysis in the future, right? So yeah.
A huge thumbs up for things to do with software engineering and associated tooling. So thank you very much. I was wondering, can you tell me, is this somehow related to the event log stuff that GHC can also spit out? And could it be more deeply integrated with that so we didn't have two independent systems?
So I've been working a bit with the event log, and the event log is like an extensible format where you can add new events later on. And it has its own serializer and deserializer. But when HPC was originally implemented, it's implemented with Haskell record, which has some fields. And the serialization and deserialization is basically the derived read and show instance. So there is no way to extend this record without breaking backwards compatibility. So the only possibility is like to either extend this record or to add like a new serialization or deserialization format.
Why do we need this is backward compatibility of what? The event logs themselves? I'm not sure we really need to be able to read old event.
HPC. So if you change the
TIX file format,
the TIX file format,
but you're going to change it anyway, from what I understand.
Yeah, I mean, so that's what we're saying. That's part of the proposal.
Right. So then maybe you could just use the event log instead.
Right.
Oh, am I misunderstanding?
So I mean, so these are kind of two things, right? So the TIX file is really just a reflection of the data structure in the runtime system, right? Whereas and then you can convert that to an event log if we could do that, right? So but we're still kind of figuring out the exact implementation. But we want to motivate it. So we have a good motivation, but we don't exactly know how we'll do it, right? Right.
Yeah.
Right. That's all we have.
Well, any other? I guess we didn't do the applauding yet. Thank you.
Also, very shortly, if you're interested in any applications of HPC or have use cases, just come to us. And we also have on the Haskell Foundation Slack, there is the Haskell program coverage channel where you can also reach us.
Okay, are there any more questions for this right away? If not, then I guess I'll get myself on the stage.
We'd like to welcome.
Yes, I always like to welcome myself, but it sounds strange. This is just happens to be the proposal that I created. It's ongoing. I seem to be doing more meta proposals that are about the process. I'll quickly say what I want to do here, and I think this is mostly a way to kickstart the open discussion, so we don't have to spend like 10 minutes on this, but I just want to like show the breadth of things from front end to back end to tools to let's talk about ourselves, because that's what committees do mostly. Typically what happens with proposals, somebody writes a proposal, we discuss it like here or on thing, and then they submit it to the committee, and we just saw it earlier, and maybe it's accepted. And then it sits there as an accepted proposal. And then there's a gap in the process where at some point in the future or in the past, anybody, doesn't have to be the author, steps up and says, oh yes, I want to actually implement this. And then they work on this, and then they create a merge request against the code, and then the whole engineering reviewing happens, which is like a separate thing. And we have a bunch of proposals that are kind of stuck after between 2 and 3. So somebody has a good idea. They convince the committee. The committee very carefully analyzes it and has long discussions, or just waves it through. And then it's accepted in the repository, and nothing happens. And I don't like that. So because I think there's some but little benefit in doing that. So my proposal would be to say that at some point anyway, like the end goal is to get it in GHC. So at some point in this process, like Norman had this concept of dominator. So the state that is merged in GHC is definitely dominated by an implementer has to be found. I propose that we make sure that this should happen before the committee gets to deliberate the proposal. So really, as part of drafting a proposal, you not only have to explain why and how, but also who. And if nobody wants to implement this, then maybe the proposal just isn't that's interesting. Main reason doing that is simply to save committee resources. It's volunteers. I'd like to focus on those proposals that actually will be implemented in a timely manner. If we had infinite resources, I wouldn't make this proposal. But another side benefit is that it actually nudges the authors to go out to the community and talk about their ideas and get not only feedback, which is what we want them to do, but also then maybe find somebody who cares about implementing it. And another minor benefit is that if there's somebody to take over the moment we accept, then the baton gets never dropped. Like the moment we accept it, it means, hey, you said you will implement it. Now it's your task to do the next step, which would be to open an issue against GHC or to link the two if there's one already. It's a minor thing. I want to point out that creating and discussing pull requests is always fine. You can do this with like vague ideas. And we discussed a little bit. I guess I just want to hear if there's any more opinions about this here before we go to the open discussion. And yeah, Gershon.
I want to propose an alternate solution to this. And what I want to do in particular, though, is I want to motivate the benefits of unimplemented proposals, which is something I didn't fully appreciate on the technical working group until David motivated it to me. And he explained, look, the Haskell Foundation wants to go out and get a lot of support and people giving it money to help pay for all sorts of good things. And the more things we have that are queued up and ready to go, and we can really explain and show and motivate and say, look, we could fund this, then the more we're able to present that, right, which is sort of a law of bureaucracy, right, is that, if you're in a university department and you get money for a year and you don't spend it, you don't get as much money next year. So we need to have everything ready to, show people that if we get resources, we're ready to go. And having really good proposals queued up, I think helps with that. David looks like you might disagree, but anyway, so what I wanted to motivate as a counter idea, just to finish the thought, would be, what if we say, if you have an implementer, you move to the top of the priority queue for discussion, right? So we don't let proposals without implementers block proposals with implementers, but we still would like to think about all of these and build up a backlog of some sort. And now I'll let David tell me why I mischaracterized everything he said.
This is a great session for the physical health of the student volunteers.
Hi, I don't actually think that you mischaracterized what I said, but I actually think that use case is better served by Joachim's proposal here. And that is because a gigantic gigantic unsorted queue of unimplemented proposals is not, I think, a particularly useful tool in the ways you're expecting. But if people are looking for an implementer, then they can come to our technical working group that looks and thinks strategically about our technical agenda and say, may we list you as the implementer, which basically means like, will you pay someone to implement this? And I think that is the right time to have that discussion, like once a draft is completed and they're looking for an implementer.
Yeah, I want to ask, have we reached out to the people that have submitted proposals and haven't done anything on them? Like, have we even asked them why nothing has happened?
No, but it was explicit that it's okay to submit a proposal that you don't want or can implement yourself. We don't want just the ideas from those people who are keen on running Hadrian. Do you know what Hadrian is? If not, then you still should be able to submit proposals. So in a way, it's not a bug. It was according to the specification of the process that these proposals are accepted and just lingering.
I mean, I want to voice support for this proposal. I think that there's now a handful, more than a handful, there's a bunch of proposals that are accepted and unimplemented. And I know just the authors of those proposals, I've gotten messages and other communication saying that they're frustrated that they went to all of this work of writing this proposal and pushing it through and then nothing. So that's one part. And then, in terms of committee time, it's, the time to debate these is non-trivial, and so it's not even a matter of prioritizing some proposals over other proposals, but it turns out it's prioritizing debating proposals versus lots and lots of other things, and so I think that's an important sort of consideration here.
I know I mentioned this to you personally before, but I just want to have this example that pattern synonyms, which people seem to like, we got pattern synonyms because there was a several years old unimplemented proposal that I stumbled upon and looked like a fun thing to do. So there are examples where people just want to build something and they might not necessarily be coming up with these pie in the sky ideas, but it's good to have something where there is consensus that it would be a good idea. So putting the effort into the implementation is worth it. And my other question is, so who's the implementer named for this proposal?
That is in fact me, because the proposal is actually not a new proposal, but rather a change of the bylaw. So I've actually implemented it already. It's a ready pull request. It is the proposal itself.
Just to be clear, though, because you didn't say this explicitly, it would be totally fine for somebody to make a pull request on the repository and engage in, months and months or years of discussion with the community and members of the committee before submitting the proposal to the committee. I think that's really important, because then the act of articulating a proposal and discussing it often is extremely clarifying, right? And then you might think, oh, now I can see there are lots of people who want this, so I'll look for an implementer. Or maybe I've got discouraged, there's too much controversy, I'm not going to bother. You see what I mean? So it's really important
absolutely,
that you could totally use the creation.
Yeah.
But this means in the process, not somewhere else.
Right.
Actually,
right.
Yeah.
Okay. I think I would. Okay, one more to this, and then we'll try to get more relevant things than just our navel gazing on procedures.
Okay, last one. So when you assess a proposal, presumably there are some things that you have to assess within that proposal. I don't know whether you have a list of points that you're supposed to take into account and things that you're not. But if you're going to have an implementer on the proposal before it's submitted, then you also need to discuss whether who that implementer is going to be taken into consideration. And I don't know whether that's a good idea or a bad idea to take that into account, but it should probably be discussed before this is formalized.
So you're suggesting we just ask the authors to say, yes, I know there is an implementer, but I will not reveal it. And here's a SHA hash of his name. Okay, thanks. I would suggest for the remaining, 35 minutes, we'll just open up for general discussion. But general open discussions often have this depth first property where the first person who speaks something dominates the discussion. So I think I'll just open a notepad, and we'll. Oh, not. It's been a while since I did this. So for the next 5 minutes, you can ask any questions or propose any discussion. You're not supposed to comment on any others. We'll just collect them here. And so that you see all the things you can then comment on, and then we'll have a wild discussion going wild and wide. But at least we see like all the other things that could have been discussed. I hope this works as an experiment. Yeah, Richard raised his hand.
Thank you. And I appreciate that you running around. Should the GHC proposals process or some other process also cover binary interface of GHC? So we've talked about sort of the user-facing interface, but not the binary interface. And what I mean specifically is GHC API, plugins, things like that. That community has repeatedly sort of said, we need a place to discuss design ideas and evolution and such. I don't know if we're the right body to do it or not. But this is not just navel gazing, because it's an issue that's come up several times.
Yeah, thank you. Any other topics that are dear to people's heart?
This has come up in the past before, and I'm sure that stakeholders are aware of the value of this. But there have been efforts to turn the compiler into a library of APIs, and I really don't know what the status of that is. But perhaps we could sort of just remind ourselves and everyone else about the value of this and how it opens up to, like more projects and more add-ons and extensions and people that can build on top of GHC. Because right now, as I understand it, a compiler is quite monolithic.
Okay, thanks.
Yeah, so it's a bit related to the first one, but different thing. So, should we add more plugin points so that we can play around with things that are proposals, but kind of implement them separately from the without having to change GHC itself?
So some of these topics form a strongly connected graph and of being related to each other. I like one. What do we do if we want to go towards stuff like dependent Haskell, but then there are existing idioms and features that don't work well with that? Like, what is our strategy, in particular with punning of constructors? Just to get the discussion a bit more interesting here. And while on type, you can maybe have one or two more to collect.
I can check the air meet.
Oh yeah, good point. Thanks. I hope it's still open.
We can also talk about proposals that people talked about already.
Oh yes, of course. All the. Yeah, I just want to make sure that you see the topics that are on the table, and we don't get bogged down in one. And I guess eventually I'll just give up on trying to give more structure to this, and we can have a really open discussion. But anything on AirMeet?
It seems to be mostly Edward Komet and Andreas Klebinger talking to each other.
Yes, they had a very serious discussion after his, and looks like they're happy. Okay. Oh, there's more. Yeah. Just shout it in. I'm typing it anyway. Sorry, say again?
The GHC release schedule.
Oh, good one. Yes.
I'm not sure if this is applicable, but Pepe Sylvan and I were talking about moving HLS into the GHC root directory.
Yeah, that would be technically out of scope for the committee, but it's certainly in scope for this discussion. if people think it can be usefully discussed. Okay, I think since we have now 30 minutes left, I will move over there. So I'm not going to tap into to like try to put structure here, and now it's really open for all. So feel free to comment on any of these and comment on and answer people and yeah.
It's more of a question related to the last thing we talked about before this. Is there any list of proposals that have been accepted that have no one working on them?
Almost. So this is part of like the whole in our process. On the GHG proposals list, there's a list of accepted proposals. So these are them that have been marked as accepted. And then there's list of proposals pending implementation, which is the inverse of that list. The problem is that the data is not very good because the accepted proposal, it's marked as accepted. And then at some point, somebody might notice, oh, actually somebody started working on it, and then add a link to the merge request to the proposal. And then at some point, somebody noticed, oh, this has been implemented last year. Let's give it a tag. The proposal simply doesn't, there's no way of automating it, and there's no good way of keeping it sequenced. But yes, if you go to this list, you will find lots of proposals that we currently believe have not been implemented. And either you implement them or you tell us, hey, this has been implemented, then we can make this list more accurate. That would also be useful.
Deep assumption. Implemented. Released. Yeah, mark it.
I'm not logged in here. Yeah, ideally also tell us which release it has been implemented in, because we have metadata on the proposals, like a link to the pull request or merge request and the release it actually was part of.
It would also be good to have distinction between is implemented and someone wants to work on it.
So he says it's also good to be distinguishing between it's implemented and it is being worked on. Yes, please. I guess this would all be easier if from the point we have the acceptance, there's somebody taking care of the implementation and can keep the metadata up to date. But yeah, this would be nice to have. I don't think it's easy to actually enforce that because there's no way of automating it easily. And yeah.
I have what might be a provocative comment related to, I think it's point 6 in your to-do list.
Sorry. Oh, how does this work?
Oh,
there we go.
Yes. It is unthinkable that we would release GHC without a working GHCI. And yet it is regularly the case that we release GHC without a working HLS. I think if not already today, within 3 to 5 years, HLS is going to be much more important to most users of GHC than GHCI. These are merely statements of what I think to be the fact. I don't recommend any particular course of action.
Very subtle. No, okay, fair enough.
Yeah, this is for point number 2. The librarization of being able to use it as a library has made things like it's made it a lot simpler to make like nice tools that do very cool stuff, because we don't have to call GHC as a binary with weird flags all the time. So I'm really glad we have librarization. So yeah.
Also on point 2, I mean, the librarization of the compiler is great, especially when you're working with plugins and stuff. The thing that sometimes frustrates me is that GHC has a tendency to change enormously between major versions, to the point that some of the plugin code that I've written, I've been able to maintain reasonably for 4 generations before 9.2 came and literally whacked the entire code base out, and it has to be entirely rewritten. It would be nice if the API could be kept mostly stable. I understand that's obviously not always easy, but yeah, some sort of even just tracking about how much breakage could be expected from a GHC version.
I think this is also very relevant to what was discussed at HIW with like the whether we want to grow the GHC API or whether we want to design the API. And I think from that discussion, I concluded that there's quite a bunch of people, or mostly that most people are in favor of designing the API. It's just that it's hard and nobody really wants to do the work and start it because it's hard.
I wanted to jump on the HLS comment thread just for a second and say that, building on David's comment, currently there's, I think, a laudable aim for HLS to be a kind of independent, separately evolving tool. But I wonder how reasonable that is given the change in the underlying GHC. Like, maybe we have to accept that HLS, like GHCI, the HLS for GHC 810 is not necessarily going to keep evolving in the same way that the HLS for the future versions does.
Yeah, so there's been a bunch of things on point 2 and about the API, and I should bring point 1 too, because that's the same discussion. So first thing first, so the GHC proposal process says that it's concerned with any user-facing changes, and I do believe it's uncontroversial that plugin authors are users. So by definition, yes, I think discussion on the GHC API and plugin, etc., are part of the committee's attribution. Being said, there's no GHC API really, or non-designed. So the bootstrap, it's difficult to bootstrap a conversation on this, right? So the first GHC API proposal will probably be a massive amount of work and discussions. Or maybe it's we start by doing very tiny things, and at this point we can commit to stable APIs, but that Jamie wanted. Today it's not possible. I think Simon will opine on that later, but it's just, and there's nothing to be stable, right? It's not quite the point of what was made. So I think that were my 2 points, or my 1 point. I don't know. Anyway.
I'll quickly interrupt with a question from Amit so that these people don't feel left out. Edward asks, is it possible that we could ever get to a world where the primary GHC data types aren't rat nests of undefined holes so that you can generic program over them without crashing constantly? That's a good guess to put the microphone there.
I don't know how to respond to that. I don't think core is a rat's nest of undefined holes. Core is a beautiful data type with 8 constructors. And we'll have to interrogate Edward later, or maybe he can amplify. If he's writing there what he means. But just to back up what Arno says, I'm sort of responding to. I guess it was your comment saying, can we not break the API? But I think if we knew what the API is, we could try harder not to break it. Right, but at the moment, what we can't say is that we will not change the type signature of any function anywhere in the 750 modules that constitute GHC. That would be absurd, right? So we have to, but then we need to develop what the API is. And I think, David, you're sort of, as far as I remember, you kind of signed up to saying you'll convene a group to talk about this, right? Is that true? Because I think that would be incredibly helpful, and there are people in the room who could be really useful in contributing that discussion. And just to sort of, before I lose the microphone, I think the GHC steering committee that judges sort of language proposals is probably not the right skill, not the same skill set as the people like the HLS authors and the people like you who are using the GHC as a library. So I think actually a different group might be quite helpful, just to spread the load.
I think that I had not formally put myself on the hook for that, but I'm happy to do so at this moment. So if you would like to participate in some discussions about this and you're using GHC as a library somewhere, and I don't know about it, please send me an email sometime in the next couple of weeks, david@haskell.foundation, and I'll try to see if we can get a little group together that can start off a process of figuring out what an API could be.
Cool.
So I have a few sort of smallish points and then a bigger one. So the smallish points are, I think it's really interesting. I don't know what to interpret, but I think it's really interesting that of the talks that happened up here and then these points, there was one talk up here and one point up here about the language that GHC compiles. Everything else that we're talking about is other stuff. So what that says to me is that it's other stuff that sort of, attracting people's attention. This isn't, there's no value in this at all, but no value judgment is what I meant in that sentence. But I just think, I think it's quite interesting because it's not what I expected to happen today. I guess the big question I had, because I think it's so useful having an audience here where I can get sort of a read of what people think. As I want to talk about, which one is it? Number 4. So if I can, I'm going to briefly explain an existing proposal that's under consideration right now, and I'm curious for some live feedback. So actually, how many people in here already know the punning proposal? Okay. So so I'll take 2 minutes to explain. It's quite simple. It's very common in Haskell to make a declaration like, especially with the new types. New type n equals n int, where n is both the name of the type and the name of the constructor. Of course, we can do this for data types also. So ASON does this, right? There's, I think, the main structure that stores JSON. There's a constructor called bool, and it stores a bool. And so you have a data constructor name that has the same name as a type. The punning proposal is about introducing warnings when you do that. So one warning when you declare such a type, and a different warning enabled separately when you use an identifier that exists sort of at both levels. And then because when you have a warning, you need a way of avoiding triggering the warning. The proposal also includes a facility for augmenting import statements with sort of an annotation that says, I just want to import type level names from this module, or I just want to import data level names from this module. And then you can use those in combination with qualified to sort of disambiguate between types and terms. That's the proposal. What's problematic about it is that it sort of seems to be taking away something that Haskell has had for a long time. This notion of being able to repeat yourself at the type level and at the term level has been around for a long time, and it's quite commonly used. What's good about the proposal is that it pushes us, or it allows those of us who want to program in a more sort of dependent style to be able to mix types and terms more freely without confusion. Or do we mean a type here or do we mean a term here? If an identifier has a unique interpretation in either namespace, then we don't have to worry about that distinction. It can only mean one thing. So I'm curious. This is adding warnings. Some people are saying this is just adding the warnings is like taking away something fundamental to Haskell. I don't know quite how to phrase the question. I guess maybe how many people. I don't want to ask for support. How do I ask this question? I want to sort of get how many people are sort of know that you're against this. Adding the warnings, that this is sort of moving us away from what makes Haskell Haskell. No. Oh, thank you. No. These warnings are all off by default. Not even in W all. You could turn them on with W everything. At some point, we're going to need W I mean it everything, but we don't have that yet. Okay, so I see a few hands going up. Is this? Oh, that's wanting to speak. I'm happy to see the mic at this point. I want debate about it, but I also want to get a sense for it. But I realize I'm throwing this out there. It's hard. I don't want to sort of force people to vote or something like that without much more information. Does anyone have a good idea of how to?
Richard, you can go to the lectron
okay.
and then, or maybe we can get more microphones from the audio room.
I mean, maybe answering the question will make the question clear, but of course the instance of this, right, is tuples and lists.
Okay.
So my first question was, does the proposal account for tuples? And I mean, I guess sort of there's already backtick for lists, and is the way that we're going to the sort of promised land that this is pointing to, does that sort of, I guess I'm done. Does that look like what we do now with sort of disambiguating lists as types, square brackets as list types versus square brackets as list terms, or does it look different from that?
So in answer to your question, there was another proposal already accepted and implemented, I think, actually, that comes up with other names for tuples and lists. So list is spelled LIST. You can import it from somewhere or other. And then there's a whole family of things for tuples. So that's already around. So people who want to avoid that particular pun can.
I feel like 2 years ago, I would have been against, well, yeah, maybe not against the warnings, but against the idea of removing the idea of punning from Haskell, because it is something that is used a lot, and it feels somewhat like part of how people use Haskell. But I just realized that I have become more sympathetic to this idea since I have started a PhD and started writing more type level Haskell, and been not very much liking all the quotes. So I think that there is a correlation between level of support for this idea of removing punning and going to dependent Haskell and academia. And this makes the discussion very dangerous, but I do think it is that the correlation is there and it needs to be mentioned.
While the microphone is traveling, everyone can continue. We are happy to say in this proposal that everyone who wants to continue using punning forever can continue to do so. This is a warning that is not on by default.
Oh.
Okay. When I program in Idris and I mess up my namespaces, I always wish I'm programming in Haskell where I don't have to worry about it. And so this is a step in that direction for like in Haskell. What I mean by that is a step in the dependent type direction, but that's not really what this proposal is about. What I want to emphasize is it's easy to think of this proposal from my experience point as a quote unquote expert Haskell person. And that means I'm not thinking of it back in like 2011 when I was learning Haskell, right? And so when I would teach students Haskell in our functional programming class, they would always be confused by the punning universally for weeks, no matter how much I emphasized type level, term level. So the ability to have the compiler say, no, you have now punned and confused these two, I think is a good thing. So I'm +1 for the warnings.
So I think I have a slightly more radical take than Richard. I see as punning as a superficial property of the language. It's like optics, probably the wrong term in this context, but it's how it looks. And unifying the namespaces and all the things you can express there, that's a fundamental improvement to the language. And to me, the question is, well, if this was a new language, I would be no question. We wouldn't do the punning because obviously the ability to write dependent Haskell code in a nice way across the ecosystem is certainly stronger. The question is, for me now, is do we want Haskell to be that agilely evolving that punning code becomes legacy code? It will be supported. You can still write it, but it becomes something like N+1 patterns that were cool once, but then we removed them because they're not actually that great and they get in the way of other things. And maybe we wouldn't remove this, but we would. I think I'm tempted to think of punning, even I'm still using it everywhere, to be something like N+1 patterns. Like, okay, might have been a good idea once, turned out that it doesn't play well with other things. And we, as slowly as we can, or as fast as we can, as slowly as we have to, we want to move away from it. Or is that too much of a change for a 30-year-old language? And if I want to do these kind of things, it's no longer like I should look at other languages. Or should we work harder in finding a way of doing dependent Haskell with 2 separate namespaces? But I think we've tried that.
So as a big user of punning, I'm of course against unifying them, but as a sort of type level programmer, I'm all for this. So I don't know what to think. So what I would like, what I would like is you to tell me what am I going to do instead of punning, so we all do the same thing.
Start your constructors with MK. That's what I've been doing.
Yeah, I did that like 40 years ago. That was.
If I'm honest, I don't like doing it either, but it's better than the alternative.
I started writing cores everywhere, so I don't have to write menu type constructors anymore. That solves most of the punning problems and makes the code actually easier to read sometimes.
I'm a little surprised that this is a big deal at all, right? So Joachim, you may think of it like legacy n plus k patterns, and I might keep punning until the end of time because it's just a warning that is off by default. Why is this taking so much of our bandwidth?
Well, because of library design,
library designers are free to do whatever they please.
But if libraries are designed whatever they please, they don't work well together. If using libraries that use punning is tedious when you're writing dependent Haskell code, that's annoying. If you're used to punning and then you find libraries that follow a different idiom, that's minor annoying, but still annoying. So I think it would be nice to have a vision that kind of takes everybody along, or at least gives like a main direction, rather than just do whatever you want.
Okay, so I'm going to start with a very broad point and narrow down. The broad thing, I know it's like, as academics and theorists, it's very easy to say it's just your surface syntax, like doesn't make a big difference. And I think it's extremely misleading. So over in one corner of the broader PL community, there's been a big debate about this. So someone like Bob Harper would say that it's like the libraries that happen to be in the standard language don't really matter compared to its core semantics. So he would say that it is ML supports, standard ML support for monads is no different from Haskell support for monads. The fact that do notation exists is immaterial. And I hope I don't need to argue strongly in this crowd that it makes a massive difference, this superficial thing. So narrowing in a bit, and I think punning is a great thing to have, and that's losing it or making it harder to do it would be an extremely bad thing. The reason is simple. That's like by losing punning, we're losing a great, very valuable part of the namespace that can be used for things that make a lot of sense. So I'm a huge fan of punning here. And so why would someone be opposed to just having the option to turn on warnings? Who in this room could possibly pose that? And I do. And the reason is that, so like how would you want Haskell to look? Do you want to endorse Haskell that's full of puns? Do you want to kind of frown on them as a bad thing that no one should use, but you couldn't use? And to the extent that turning on this warning, that having this warning is kind of a nudge to the broader community to start rewriting their code to not have puns, I think is a bad thing.
So if I can, I would like to actually call something that where I see raises of hands, and then and with an open invitation to move the conversation elsewhere, just because maybe there's other topics that people want to bring up. If you want to keep talking about this, raise your hand and keep talking about it. But I'm quite curious. Can I see a raise of hand? People who are confident that they would support this proposal to add the warnings, and people who are confident that they would want to reject this proposal to add the warnings. Okay, thank you. That was helpful.
Can we have plugins emit warnings? Sorry? Can we have GHC plugins emit warnings?
There's no reason why not. I don't know if we have that today.
Sort of the plugins.
So I'm someone that does a lot of punning, but I was very compelled by the argument that students often misunderstand punning, because I've 100% seen that in the past. And I guess I would characterize punning as almost a Haskell design pattern. And it's controversial opinion time. I don't think design patterns are a good thing. I think they're usually pointing at a deficiency in a language rather than something we should be doing. And so I wonder if there's a way that we could replace the need for punning in a way with something that just works better, reduces the boilerplate, and frees us to start unifying type and value names.
I guess I just want to respond to that point briefly, because I find myself on both sides of this, but a simple example, I guess, Traversable is a beautiful library, and the fact that my sort of beginning Haskell students are calling null on maybe values is terrible, right? Because it's sort of indicative of a mindset that they have that I'm trying to break. I think that tension is inevitable, right? There are always going to be things which are sort of useful to professional Haskell programmers or to sort of experienced Haskell programmers, but pose a challenge to beginners. And I would be hesitant to let the language design be driven too far astray by, trying to sort of pick the worst of both worlds, rather than having some sort of consistent approach to saying how does the language experience evolve, for people as they learn the language.
Since this is GHC proposal session, and we're supposed to also discuss things that are just being under work, what happens if you have a built-in class new type in a MIC that you can use type application, and you just write mid at age, and then you never have to mention any new type constructor besides this one? Would this work? I mean, just throwing it out there into Richard's head, and we can take it way later. But maybe the win-win situation is indeed, can we make Haskell need less punning so that punning doesn't become a point of contention anymore? And punning in a way repeats things, so that's generally not a good thing, right? Like, you don't want to write things twice in general. So maybe there's a way of having a win-win situation.
I don't have a response to that. I have a response to the earlier thing, because something I was thinking about is we have another extremely controversial libraries proposal, which is about adding a warning to the head and tail functions. And Simon Marlowe has been screaming his head off that please don't do this on that ticket. Yes. I don't mean it in a mean way. And I think what the last comment though points to is that there's this that the idea that we're going to use warnings to sculpt end users' behavior causes a lot of anxiety, because then you feel like, well, if there's a warning, then even if it's off by default, then you're saying what I'm doing is wrong because you're warning about it, and it's my style and I have my reasons, and you can't judge me, you're not my father, right? And so it generates this, and I'm not saying I have a particularly good answer for this. I think with the proposal we have now with the type namespaces, there's other reasons besides like language levels to pursue this for a different vision in the future. But in terms of warnings that prevent sharp edges of the language, maybe we need to reframe it in a way that doesn't make people feel judged when there's a warning that exists that might warn against the thing they're doing. I don't know how to do that.
So I'll get a comment from Airmeet in. So Edward says, the MIC convention takes more space and adds noise to an otherwise beautiful language. Uppercase constructors similar add noise. And ironically, we have a global convention for working around that, which is you can use the tick to talk about the term constructor in the cases where you do need to ambiguate. And this doesn't take any user namespace away from them. I guess that means he's more in favor of finding a world where punning and dependent types work well together.
Yeah, so I want to bring this back into the plugin points, right? If there was just a punning warning plugin, and then people who want this warning can just pick the subset of Haskell they want, right? And this is what we do with language extensions. Like, you enable things that you want to have in the language, and then you don't, so you kind of, and that's one of the beauties of Haskell is that you can pick the language you're writing in, right? So I don't know, not making it a warning and making an extension is another option, right?
You talk about plugins in that way. The word "just" is doing an awful lot of work. I think that GHC doesn't contain spyware, so I don't know. But if I had to guess, I would guess that less than 1% of GHC users have ever used a plugin. I don't think I ever have. And that anything relying on plugins is automatically going to attract the experts and nobody else. But I may be wrong about those things. But
So it's unfortunate that, I mean, as always goes, when the discussion is most heated, we end the end of the session. I think it would be good to end early for the people who want to go away. And I invite you all to just continue this discussion on the various forums. So the GitHub proposals process, of course, the GitHub page. Also the general questions, just, I guess the mailing list works. And I'm sure people are also happy to discuss on Discourse and other places. And now, of course, the hallway track. With that, sorry for cutting it short, but I guess we have to cut at some point. It will not be easier to cut in 5 minutes, but then we're late. Thanks for being here, for discussing this, and maybe we can make this a regular thing in some way and improve upon the efficiency of this session. But I had great fun, and I hope you too. Thank you.